Hello, today we're going to be working in our Envisions math book on topic 4.4. It starts on page 183. So if you could please get your math book and open it up to page 183, you'll see a yellow sports car on that page, and we're going to work a problem on that page. We'll also be working on page 184, 185, and 186. So we'll hit a few problems on each of those pages. So pause the video and open your math book to page 183. Okay, so I have our problem on the screen. There's our sports car, and we'll just jump right in. A car travels 1.15 kilometers in 1 minute. So that would be 1.15 hundredths of kilometers in 1 minute. If it travels at a constant speed, how far will it travel in 3 minutes? In 5 minutes? Solve this problem any way you choose. Okay, so like I always like to do, come up here and just kind of start at the beginning. So in other countries, they don't use miles, they use kilometers. So that's why they're talking about kilometers. So it's 1.15. I'm kind of thinking of miles, but I guess we're going to talk about kilometers, miles in 1 minute. Maybe I'll make a chart. So here's how far we go in kilometers. If you really didn't want to say kilometers or that was tripping you up, you could say miles. And then this is how many minutes it took. So 1 minute. Okay. So now we're trying to find out how far can the car go in 3 minutes. This is 1 minute. So we're going to multiply because we're adding repeatedly. So you could say in 3 minutes, it's going to go 3 times as far. You could even add it up. And maybe I'll start there and just say, so in 1 minute, we're going 1.15 or 1 and 15 hundredths of a kilometer for 1 minute. So in 2 minutes, I could add those up and then I'll find out how far we'll be going in 2 minutes. So I'm going to add 5 and 5 is 10. Put the 1 up here in the ones place, 1, 2, 3. I don't know if we learned this yet, but you need to line up the decimals. Okay, so your place values are in the right position. So put your decimal right there. 1 and 1 is 2. So that really wasn't too hard. Okay, so in 2 minutes, it went 2 times as far, or twice as far. Okay, 2.30 kilometers, or 2 and 30 hundredths of a kilometer. Okay, so that's not the question though. We're trying to find out in 3 minutes. Well, I guess I could add, 2. So this was 2 minutes. So how would I get from 2 minutes to 3 minutes? How far would we go? Maybe now I'm going to do a picture that I can even draw over here. This is how far it goes in 1 minute. 1.15. Okay, oops. 1.5. That's for 1 minute. And I like to put my little dots right there so I remember. Okay, he went this far in 1 minute. Then in the second minute, he went the same distance. So again, that's 1.15. And we found out together 1.15 plus 1.15 is 2.30. Now I'm looking at 3 minutes, so I need to go another minute, which takes him another 1 and 15 hundredths farther. So how would I get my answer? How far did he go in 3 minutes? So you could take 1.15 plus 1.15 plus 1.15 and find out how far he went in 3 minutes. You could take this 2.30 and add on that last 1.15. I guess I was thinking of it that way for a minute here. Okay, so 2 and 30 hundredths plus 1 and 15 hundredths. Sometimes I like to just say it the right way so I don't forget. Would be 5 plus 0 is 5. Okay. And then 3 plus 1 is 4. Make sure you have your decimals lined up. This will be very important. So you have your ones in the ones place. And then 2 plus 3 is 3. So it would be 3.45. Now, to be honest, I'm not going to be able to do this all the time. So instead of adding 1.15 plus 1.15 plus 1.15, I could have said 1.15 times 3. I see it here 3 times. So that would have been another easier way to do it. Let's see if that would have worked out. If I had 1.15, how would we set up our problem? Just do it the same way you would as if you didn't have a decimal point there. So I write one factor on the top. Now I always have to line up. I used to do this when I was younger. So line up your numbers that way. So 1.15 times 3. Look back up here, 1.15 times 3. And make sure these are lined up. You can't have the 3 over here somewhere. They all have to be lined up on the right side. Just like when you write a paper, you line your words up on the left side. So that's just how it is. Okay, 3 times 5 is 15. So I put my 5 here. And then you carry the 1. 3 times 1 is 3, plus that 1 on the top. Okay, 45. 3 times 3 is 3. 3 times 1 is 3. Okay, so we got a different answer. The correct answer is 3 and 45 hundredths, or 3.15, and I have 345. Well, first of all, if you took 3 times 1, your answer would be 3. So if I use my math reasoning, does that sound reasonable? Does that make sense? 3 times 1.15 is now 345? No, that really wouldn't make sense because this answer has to be kind of close to 3 because 3 times 1 is 3 and this is just 3.15. So you're just a little over 1. So my answer should just be a little over 3. But technically, not just guessing like that, I can also look, there's 2 numbers on this side of the decimal point. So I'm going to take a different color just to show you. And once I do this one time, you'll kind of catch on. So there's 2 numbers on the right side of the decimal point. So I count 2 over. 1, 2, and then I put my decimal right there. Okay, let's try times 5. That was also part of the problem. This is how can addition be used. We just showed addition. We don't need to do that again. But let's try 1.15 times 5. So how far can he go in 5 minutes? So it'll be 1.15 5 times. So I could add up, like they said below here, I could add up 1.15 5 times. We'll extend this out. Bam, that's in 4 minutes. Bam, that's in 5 minutes. But of course, we can't add up, all the time like this. I mean, you would get the right answer, but it would be tedious. We can kind of estimate, just so when we check our answer, we can see if it's exactly right. So what would 5 times 1 be? 5 times 1 is 5. So I'm pretty sure my answer is going to be close to 5 because this is just 1.15. It's 15 hundredths larger than 1, but it's not to 2 yet. So it's close to 1. So let's take 5 times 5. That's 25. 5 times 5 is 25. I carry my 2 because there's no room to put the 20 down there. So 5 times 1 is 5 plus 2, 7. Okay. I always put a line in my 7. My dad used to do that. Okay. And then 5 times 1 is 5. All right. So now we have 575. That can't be right. But remember, we count our decimal, how many numbers are on the right side of the decimal point, and there's 2 here, the 1 and the 5. So there's 2 there, so I count over 1, 2, and I put my decimal. So the answer is 5.75. All right, let's go to page 184. Okay. The ticket price to a minor league baseball game increased 7.17 times last year's ticket price by 17 hundredths times last year's ticket price. So not very much. It didn't increase very much. It wasn't like 2 times. It's 0.17 times last year's ticket price. If last year's ticket price was $26, how much is the increase? I would say not very much. So you can multiply 0.17 times 26. Okay, so if we look up here, we can see that's kind of what it said, 17 times last year's ticket price, which was 26. So even if I don't understand it yet, I can see that's what they're saying. 0.17 times 26. All right, so how are we going to multiply as you would with whole numbers? Okay, so we're taking 17 times 26. 6 times 7 is 42. You put the 2 down there and the 4 on top of the 1. 6 times 1 is 6. Plus 4 is 10. So then I have my right here. That's my partial product. So then I put the 0 over here to hold my place value. And then I take 2 times 7 is 14. Put the 4 down here and then the 1 in the tens place. 2 times 1 is 2 plus 1 is 3. So there's my other partial product. And then I add them. And I get 442. But please remember, this was actually 0.17. And there's 2 numbers on the right side of the decimal. So I'm thinking I'm going to count 1, 2, and put my little decimal point right here. Uh-oh. Let's check it out. Well, here they're going to explain why that is. So what they're trying to say is if you times 26 times 17, you would get what we got. Yay, 442. But if you times 1.7 times 26, Well, 1.7 is a tenth of 17. So that means your answer would be a tenth of this 442. So then you would take and move your decimal over 1 because you had, this was 17 and you moved your decimal over 1. This was 442 and you moved your decimal over 1. So really we had 0.17 or 17 hundredths. So we're actually taking a hundredth of 17. So we're going to have to take a hundredth of 442. So kind of like I said, you see the decimal was right there when it was 17 times 26, but it wasn't 17, it was 0.17, which is a hundredth. So I moved it over twice. I moved the 17 over twice, the decimal over on 17 over twice to get 17 hundredths. And now I have my answer, 4.42. The factors have a total of 2 decimal places, so the product has 2 decimal places. So the increase is 4.42 or $4.42. So not a huge increase. So then you can take your $26 plus this $4.42, and that would be $30.42 for ticket prices this year. Okay, so we had 2 decimal places. So this is how, if you remember, just go back here. We had 17 times 26, but then we had this decimal, which was 2 over to the left. So then on the 442, I also had to take my decimal point and move it 1, 2 over. Okay, just kind of like I did with the 17. All right, so there's the decimal. Bam, and there's my decimal. So it all worked out. All right, let's go to page 185. You know, we've been practicing a lot with word problems, so let's, we can just answer this question. What is the difference between multiplying a whole number by a decimal and multiplying a whole number by a whole number? Well, one has a decimal, one doesn't. So however many spaces you have moved the decimal over, that's in total, that's how many spaces you move it over on your final product. So let's kind of practice this. Let's start off with number 3. We'll do 3 here, and let's just randomly, we can just do 8. Looks kind of weird. Okay, so 2 times 8, well, we're going to do 9.8 times 2. First of all, I might think of what is 9.8 close to is kind of close to 10. So 10 times 2 is 20. I know 9 times 2 is 18, so it's going to be somewhere between 18 and 20. So if I get a crazy answer like 200, that's not what 9.2 times 2 is. So let's try it out. 2 times 8 is 16. So I'll put a 6 there, nothing too tough, and a 1 up there. What's 2 times 9? 18 plus 1. 18 plus 1 is 19. Okay, now I got 196. Well, that's what it would be if it was 98 times 2. But this is 9.8 times 2. So I had moved, my decimals over 1. So I'm going to have to move it over here 1. You could say it this way. I have one number on the other side of the decimal. So I need one number on the other side of the decimal for my product. However you want to say it. I just add up my decimals. I see there's 1 here. So I make sure the decimal's over 1 on the bottom. Okay, so let's do this problem. I can't do it sideways like that. So I'm going to take 55. I have to stack it up. And then I'll times it by 1.1. Oh, this is going to be a little harder. Okay, so this one now I have to get two partial products and add them. So 1 times 5 is 5. Then I do 1 times 5 again is 5. Now here's where some people would kind of make a mistake because you might forget to put the 0. Don't forget to put the 0. You might be going kind of fast. Put your 0 to hold your place value because now we're going over to this one. 1 times 5 is 5. And then 1 times the top 5 is 5. Okay. Very important, your place values. It's kind of like a pattern or a game or Tetris. So 5 plus 0 is 5. Okay. Then I go to 5 plus 5 is 10, which I can just put the 0 here. Add a 1 for my 10 up there. 1 plus 5 is 6. That's 605. All right, well, 55 times 1.1. Well, 55 times 1 would be 55. So 55 times 1.1 is just going to be somewhere around 55, a little more. So I kind of already have ideas. It's not going to be 6 something. It's not going to be 605. It'll be 60.5. And then I go over here and I see I have one number on that side of the decimal. So I go down here. Bam. I'm going to have to put my decimal right here. One number on the other side of it. So that'll be 60.5. So that's my answer. And you can make it neater. So if you're doing an interactive notebook for your teacher, go ahead and kind of write it over here. She can look at your work, but this will be easy for her to spot it. I mean, some people might even, you could go ahead and circle it, 60.5. Okay. Now, here are some more problems that you can do on your own. You can always check them with a calculator when you're done. Let's take a trip to our last page. Let's talk about problem solving. Okay, so he's saying to meet, let's try number 21. It looks kind of tough, but we're having a good time. Okay, to meet peak energy demand, an electric power cooperative buys back electricity generated locally. So I don't know how you would buy back electricity. So now I'm going to go to the problem. Let's see if I can get that. They pay 7 cents, or this is 7/100ths of a dollar, 7 cents per solar powered kilowatt per hour. How much money does a school make when it sells back 956 kilowatt per hour to the cooperative? It's still a little bit far fetched for me how they're buying. So maybe if your school has solar panels, they're buying some of that energy back. I'm not sure how they're doing that. So let's just take this problem and say we know it's going to be multiplication. So 956, you already know, times 7 cents. But we don't do 7 cents. It's 7/100ths of a dollar. Because you know there's 100 pennies in a dollar. So this is a good example of real world 7/100ths. Each penny is 100th. Okay, so I would take 6 times, this is how I set up my problem. No worries. 7 times 6 is 42. I put the 2 there, carry the 4. What is 7 times 5 is 35. Plus 9, plus 4 is 39. So I was talking, let me go back. 7 times 5 is 35, plus 4 is 39. Okay, so I put the 9 down there. Let's put the 3 up here. 7 times 9 is 63. 63 plus 3 is 66. Okay. Now I already know we're dealing with decimals, so we're going to have to put a decimal in here. And here there's two numbers on the right side of the decimal, 0 and 2. So I have two numbers on the right side of the decimal, which is kind of like a hundredth. So I need to move this over 2 spaces to get this to be a hundredth of what it would be if it was just a whole number down there. So 66.92 or 66 and 92 hundredths. So there's my answer. It wasn't too tough. I maybe don't get exactly what they mean by buying electricity and so forth, but I know what the answer is. Okay. So, and actually for that one, yep, that's right. I thought we had to estimate, but no, they wanted it fair and square. I wonder if we should do a hard one. Let's go down here to this really quick. Here's like an assessment your teacher might give you, and this trips people up because it says, which of these following equations is not true? This one also says, which one is not true? So it kind of is backwards because you might think, oh, this one is right, and this one is, so 75 times 3 is 225. So that one is actually wrong though in this problem because the teacher, this assessment is looking for which one is not true. So you're trying to find the, well, 75 times 3 is 225. And I just got that really quick because I know 75 times 2 is 150 plus 75 is going to be 225. So if I know this one is right, what is 75 times 0.3? Okay, so then I know I need to move that over one. So 22.5 looks right to me. What about 7.5 times 3? Okay, I'm going to go back up here to my original problem. Don't start looking at this middle problem where you get confused. So instead of 75 times 3, it's 7.5 times 3. So they went over 1. See how they have one number on the right side of the decimal? So my answer is going to have, oops, so it should have been 22.5. Okay, but they actually moved it over twice. So this one is wrong. Now 75 times 0.03. Okay, now maybe you might think, you know what, I have too much going on here. Let's just erase this. I want to get this right. Let's see how long this takes me to get erased. Probably took me 10 hundredths of a second, of a minute. Okay, so let's go back down here just so I can clear my thinking. Oops, this one was wrong, I decided. All right, so 75 times 300. 75 times 3 is 225. The decimal usually is right here. So I moved it over 1, 2 spots. So on my 225, I'm going to have to move it over 1, 2. So that looks right. So that was actually pretty easy. So sometimes when people look at this, they're like, wow, all the numbers look the same. So that's why they put it there to see if you can actually take the time to do each problem. I actually did 4 problems really quickly here. So let's go ahead and do this one and we'll finish up. Which one of these equations or which of the following equations is not true? Maybe I'll have one or maybe I'll have more than one that are wrong. 50 times 12 is 600. Let's make sure that's right. I'm going to put 12 at the top. Should I? I don't know. Okay, let's do it right here. It didn't work. So 12 times 50. I know a trick for doing this, but I didn't want to trip you guys up. I could have moved the 5 over under the 2 and did it. So 0 times 2 is 0 times 1. We're all looking at zeros. But don't forget to put your 0 to hold your place value in the ones place because now we're doing 5, which is actually 50. 5 times 2 is 10. And 1 up here, the tens. 5 times 1 is 5 plus 1 is 6. So it looks like 600. 50 times 12 is 600. Okay, so this is right. So this one I'm not going to check off. Okay, so I like that because now I can kind of go back to that one and see what the right and wrong answers are. So 50 times 0.12, which has 2 decimals on that side. I would have to move it over twice. 6. That looks right. Okay. What about 0.5 times 12? So if I have 0.5, I would have to move it over here twice. 1, 2. Okay, so here I'd have to move it over twice. Oh, so this is not right. It should have been 6.0. Actually, I'd have to I could have put a 0 here. And see, I moved it over twice. Then here on 600, I would have had to move it over twice. And actually, that makes sense. Because if I have 12 and I times it by 0.5, which is a half, 6 is half of 12. So if I had 12 times 1, 12 times 1 is 12. So if I'm timesing it by something less than 1, I'm going to get a smaller number. So 6 is right. So anyway, this is wrong. They had it 60. That would be 12 times 5, not 12 times 0.5. Let's try this. 50 times 1.2. I won't erase it this time. So here, 50, oops, I guess I will. Okay. So let me erase my first problem just so I can kind of get a clean version of the right answer. 50 times 12 is 600. Okay, so now they want me to do 50 times 1.2. 50 and 1 and 2/10. All right, so let's check it out. So instead of having my decimal here, I moved it over 1. So instead of having, this was going to be 600. Instead of having my decimal here, I move it over 1. Actually, it's 12. I have moved over 1. So that is, let me put the decimal here. That one is correct. So actually, the only one wrong in number 27 is C. Okay, so that's on page 186. All right, so this is not too bad. You're basically counting how many decimals over you have. So when you times a problem, if I put it 1 decimal here, then I'm going to have to put, then in my answer, I would have to make sure there's 1 number on the right side for my answer as well. What you're going to find out later is if I put a decimal times a decimal, then I'm going to add them all up. There's 1, 2, 3 numbers on the right side. So then in my answer, I would have to make sure there's 3 numbers on the right side. But we'll talk about that next time. Thank you. Put in the comments what you want to hear more about or you want explained or what topic is still tripping you up. Maybe it's an old topic or something that you looked ahead and saw that's coming up. Let me know what you need help with. And thank you for watching. See you soon.